So, ladies and gentlemen, welcome to our HIMA workshop, Big Data Meets Smart Safety. I would like to introduce myself. My name is Steffen Philipp. I'm the managing partner of HIMA group of companies based in Brühl in Germany. And I would like to introduce also my colleague Buddy Grief, who is the sales manager in HIMA Americas. Before we start with this very interesting presentation, I would like to give you a little bit insight of that what is the expectation for you. First of all, the contents. I would like to give you a brief introduction in who we are, and afterwards about the smart plant and smart safety. Then we go to the next topic, from data to beneficial information, followed by the topics HART and smart safety. And what does it mean for the benefits of smart safety? Afterwards, we have the Q&A sessions, and hopefully we will end on the 1:45. Okay, so let's start with the first chapter, who we are. HIMA Group of Companies is one of the leading independent provider of smart safety solutions. We are, as I already said, based in Brühl in Germany. Brühl is not very well known, but maybe you remember Steffi Graf. It's the birth town of Steffi Graf, so now Brühl is very, very, very well known. We are operating in more than 50 countries worldwide, and we think we have an expertise in safety because we are now handling the safety aspects since more than 70 years, while the company itself is more than 100 years old. We believe that the separated solutions are according to the requirements we have today in the standards, and we are lucky that we were always on that independent idea of the smart safety solutions. We are still family owned. I'm representing the 4th generation. Which is something maybe in the US not very common, but in Germany we have some of these companies which who are in the 4th generation, and hopefully there will be a 5th generation. Let's see. We have installed base of around 35,000 safety systems worldwide. Why is that figure so high? Easy. We started in the 70s with the safety systems, and when we count up from the 70s until today, it makes that sum. Coming back to the independent systems, we think that these international standards like the ISA 84 or the IEC 616-511 clearly define that safety has to be a separate system and not an integrated system. That's the reason why we are still working with these independent systems. Let's come to the smart plant and the smart safety. We'll show you a development which is not really new, but if you see that, not talking about the first industrial revolution, which is quite a long time ago, we started to develop a first safety system which was not a programmable system. You remember there was a time there were no computers. It's quite a long time ago, but we developed in these days the hardwired safety system, which is interestingly enough still in place, and we have a renaissance of these hardwired systems again because of the security aspect. And as I said, in the 1970s we were developing the first safety system. And another milestone was later on that we developed a first safe Ethernet protocol, which we made safe. So all our controllers are communicating via the safe Ethernet protocol. 2008 was a very, very important year because in 2008 we had our 100 years birthday, and we released the HIMAX solution, or the HIMAX controller. Which was the first non-stop safety system, and this is what you see in our logo, safety non-stop. The question is, when we are collecting data, as we are doing constantly, because it's a safety system, what we are doing with these data. And so we are coming to that question, what are we doing with the big data and what comes out with the smart data? And this is now definitely a topic which is not mine, but it's Buddy's. So Buddy, I would like to hand over to you to explain what we are doing with the data. Thank you very much so far.
Thank you. Look at that. So I guess if it's okay, I'm going to stay down here. A couple of things. First thing, since we're a safety company, we should have a safety moment. So since if there is an emergency of some sort, since you all came in the exit, I have no idea how you get out. And I want to be sure that everybody has given Nicole a business card or filled out a card, Nicole Pringle, because we're going to have a drawing at the end, and we'd love to have everybody's name in the drawing, okay? We talk about big data, you know, and I sometimes wonder, what does big data even mean? So I think what we need is, we have lots of data. And I always think the question is, how do we convert data into information? And then I was sitting at dinner last night with a gentleman from 3M, and he said, well, when you convert the data to information, you're only halfway there. He says, if you take data, convert it to information, you add knowledge, then you have wisdom. And so I think what we want to do is we want to talk to you about, can we convert data that we have into information that you can then use with your knowledge, with your wisdom, and make knowledgeable decisions, whichever way that went, okay? So what we've done for today is we've created a little green chemical plant, and we want to run this plant for a little bit, okay? So this plant is a very simple plant. It just makes this green chemical. It dumps it out. It works like a charm. We don't have any problems, right? And the safety system just sits there and does nothing for most of its life, right? But then one day, something goes wrong. And when something goes wrong, the safety system, the HIMA system steps in, corrects the problem, we dump the waste, we've lost a batch, right? But we've not harmed any people. We shut down the process, which is what you said we should do. We've not harmed any people. We've not harmed any equipment. There's been no harm to the environment. So we could argue that the safety system has done its job, right? So what we say is the first thing is I've got to get back up. Okay, I've got to understand what shut me down and get back up, because I don't want to lose any more production than is necessary, right? And almost every safety system, certainly every safety system that HIMA integrates, has a first out indication, right? So in our smart safety solutions, which is what we're going to talk about for the rest of this time, however much long it is, in our smart safety solution, we're going to bring that root cause analysis, that first out, out to a screen. And we're going to show you what happened here is we had a high pressure problem. And that's the reason we shut down. So we can go correct that problem. We can start the process back up. And that's good. And now we would argue the safety system has done what it's supposed to do, right? It not only shut you down, protected the people, protected the environment, protected the equipment. It even told you what caused the shutdown so that you could get back up. The question is, does the safety system know other things that would be helpful to you? And what we're going to propose to you is that there's all this data that resides inside of this HIMA safety system that has just kind of sat there for all these years and not been used. So somebody said, matter of fact, somebody said root cause analysis. I was at a refinery in East Texas last week, and I was talking to them about this, and I told them that I started talking about sequence of events. Oh, shucks, I'm ahead of myself. I'm going to go anyway. Let's talk to you about sequence of events. And a sequence of events is an inherent capability of a HIMA safety system. At the same time, almost nobody uses it, right? So one thing in our smart safety solution is that we'll bring the sequence of events out onto a monitor, out into a database, and you can explore that database to help you do a root cause analysis. So as I was saying, I was at a refinery in East Texas, and I was showing them this, and they said, please, every system that you sell us this smart safety solution. They said, we never buy a sequence of events. In many safety systems, it's not easy to do, it's limited, it's expensive, not the case here. They said, we never buy that, and then after we have a shutdown, they always come and ask us, how did that happen? And we don't have the data, I would say information, to do that. So sequence of events can give you the information that you can combine with your knowledge and figure out how not to have this same shutdown again, right? So in effect, we've prevented future shutdowns by being able to do the root cause analysis, okay? So that's sequence of events, and there's a sequence of events application in our smart safety solution. Next thing I want to talk about is critical alarms. You know, a few years ago, and many of you probably remember, a few years ago, all we talked about seems like was alarm rationalization, right? There were companies that were created to do alarm rationalization. I was with an engineer from a major refiner a few weeks ago, and he said, you know, we've essentially given up on alarm rationalization. We just can't really, we never get ahead of it. So we see more and more companies looking for critical alarm systems, in many cases independent systems. But we would say those critical process values probably already exist in the safety system. And so the second application in our smart safety solution is a critical alarms application. You know, I tell people I'm in my second century in this business, and in my first century we had little panel alarms, right? They only had 16 lights. So you're only allowed to have 16 critical alarms. If you wanted to have a 17th, you had to figure which one of the first 16 you're going to take out, right? So a critical alarms package allows you to see things before they shut you down and to take corrective action. So again, we're trying to prevent shutdowns, okay? I'm just going to say this is my favorite. This might be my second favorite. HIMA safety systems are high diagnostic systems. And in general, safety systems are high diagnostic systems, right? But in general, if you have some kind of an issue with the safety system, it gives you an error code. So I asked, at another customer a few weeks ago, I asked, what happens if you have a shutdown in the middle of the night? And the answer was, we all get a phone call, right? I didn't ask what happens if you have a shutdown at noon, because you never have shutdowns at noon. They only occur in the middle of the night, right? So they said, well, we all get a phone call, we all get out of bed, we all come over to the plant, and we try to figure out what happened and see what we can do to get back up. At that point, you know, with a safety system, they would typically connect up to it some way. They would go inside and find the error code. They would go look in the manual and see what the error code means. And then they would take corrective action. So with the HIMA system and with the smart safety solution, what we've done is we have a diagnostic application, and instead of talk to you in error codes, it's going to talk to you in English. So you see the square around the I/O module. and you would get a dialog box. In this case, it says replace that analog module. That tells you it's an internal fault and you should replace the module. Or what's much more likely is the fault has nothing to do with the safety system itself, it's external. In which case it would say something like there's a field fault. So in this case there's a field fault, channel 1 of slot 10. I would suggest to you that at that point, the technician who sees this can go work on that, and I don't have to wait 2 hours for all the engineers to come to work. I don't have to have a trained technician or engineer to do a deep dive into the system, right? And so I can get back up quicker. And particularly, I guess studies have shown about 95% of the time, a shutdown has nothing to do with the safety system. It's an external event anyway. So 95% of the time, a technician can handle this if he has the information. Because I would argue they always have the knowledge to deal with that if they know that's what they're trying to deal with. We agree? If I have an engineer on staff and I want to dig deeper, I can click on that module and it'll bring up a more detailed diagnostic page. So it tells me the error code is 400, and that means this, and if I click up here, it tells me what that really means is I have a short circuit on that point. So all of that is part of the smart safety application that you can dig down to if you want to. HART is a powerful protocol, gives you a lot of information, but typically when we connect HART sensors to safety systems, we don't use the HART, right? The HART is there so that I can reconfigure from my handheld, but we typically don't do anything with that data. Excuse me. TUV wrote a paper almost 10 years ago about the use of HART in safety systems and things that you have to be careful of when you're using HART in safety systems. So we would say the first thing you have to be careful of is if anybody comes along with the handheld and reconfigures this thing, then my safety system is no longer useful, right? If I think this is a 0 to 100 PSI and you reconfigure it to 0 to 200, you know, the reactor is on the moon before I know it's overpressure. So I know that we have procedures that say you don't do that. And I know that there are passwords to prevent you from doing that. I don't know how many instruments you might have in your plant, but I'm guessing if you have 2,000 instruments, you don't have 2,000 unique passwords. Most of the people I talk to as I ask this question in a plant have one password, right? So everybody knows the password. We can't claim that as a protection. Sometimes we do in fact use this information. We take it up to an asset management system. Quite often using a multiplexer to totally bypass the safety system, which is a traditional way to do that. And then we've added another risk because now it could also be changed from the asset management system, and we wouldn't know that either. So we think there's risk involved in using HART instruments. On the other hand, there's probably not an option not to use HART instruments. So how do we get around that? It's become kind of standard practice these days to tunnel the HART information through the safety system. So HIMA has a device that allows you to tunnel the information up. Our device has a unique feature in that we'll prevent you from writing to the instrument unless we give you permission. So on a point-by-point basis, we can stop you from writing to the instrument so we can save the reconfiguration from the AMS. We kind of give you an extra layer of cybersecurity, but you can still change from the handheld. So kind of our latest innovation in this regard is that what we're doing now is we're actually reading the HART information in the safety system. Okay? So let's think about what that can do, right? I get a HART diagnostic that tells me that the instrument's been reconfigured. So while I may not know what the new configuration is, I can take it out of a vote I can shut the system down. I can do whatever needs to be done based on that information. HART is not a safety protocol. We're not using it for safety. It's another diagnostic layer. Okay. So I can do that. I can. I get a HART diagnostic if the instrument goes bad. I don't want to use too many examples, but I was talking to another refiner, and they were talking about they've had a number of shutdowns where the safety system thought the instruments were bad, but they weren't. They were using the Moore standards. I don't know if they programmed it wrong. I don't know if something read wrong on what happened, but he says several times they've had shutdowns costing hundreds of thousands of dollars each time when the safety system thought the instrument was bad. Well, if I use the HART, I know when the instrument is bad, right? Even some instruments will tell me they're going bad, so I can use it for predictive maintenance. I can even using our HART technology, I can even upload the configuration, store it in the HIMA, and then if you put in a new instrument, I can download that configuration, so I know it's configured the same way as the previous one was. Okay? So we think this HART capability is a big step that eliminates a risk that we've all lived with, and at the same time allows more information that we can combine with our knowledge to make good decisions. Where am I at? There's where I'm at. So this slide just says what I already said. We actually can prevent, from an AMS system, prevent anybody from writing to the HART device. So in the end, why would you care about our smart safety solution? We can prevent outages through critical alarms. We can prevent outages through using the sequence of events information. We can minimize unscheduled downtime with the diagnostic tool. We can increase safety and security by being able to read the HART diagnostics. We can improve reliability in the same way. And in the end, all of that means you can increase profitability. One of the problems being in the safety business is there's no ROI. Or what I say, the ROI is either infinite or it's non-existent, right? But here's where information from your safety system can actually save you money and or make you money. And that's pretty much me. Questions?